video, we're going to cover Unit 1, Lesson 3 for Algebra 1. This is interpreting function notation in the real world. Benchmark over here, given a function, represented in function notation, evaluate the function for an input in its domain for a real-world context, interpret the output. So remember, input's the x, output's the y. Learning target, I can evaluate a function for a specific input value of the domain and interpret its real-world context. So we've got a warm-up over here. This one's a little tougher. So it says fill in the box to construct two functions where the final equality statement is true. Use digits 1 to 9, so no negatives, no 0, nothing over 9, once each at most. So you can't use them more than once. And so what this is saying is that f of x equals blank x minus blank. So we're going to put numbers in here, and then this represents x. So we got to think about three numbers that we multiply two of them and subtract one, we get 26. So let's think about 9 for a second. Let's just say this was 9 times x. If we go 9 times 9, you got 81. Way too big for that. So you want to go smaller. 9 times 4 is 36. 36 minus 9 won't give you 26. So let's try, let's make x 3. So 9 times 3, because remember, this is this guy. So 9 times 3 is 27. 27, so that's 27. 9 times 3 minus 1, that's 27 minus 1, which is 26. So that works. You could also say, let's just say 8 times 3 is 24. You subtract 1, you're not going to 26, so you're going to have to go bigger than 3. So what about 8 times 4? Minus 1. Well, not minus 1, excuse me, minus blank. So let's see what we're dealing with. 8 times 4 is 32. What would we need to subtract from 32 to get 26? That's right, 6. So 32 minus 6 would also give us 26. So we're just playing around with numbers. Don't let this throw you off. It's trying to teach you that g of x, or whatever this is that variable. So with this altogether should equal what's on the outside here. Hopefully I didn't throw you guys off too much. All right, page 17, 1.3.2. Interpreting functions. So recall that all functions have a special notation which follows a unique relationship to be expressed in a concise and meaningful way. The value of a function is dependent on the input, and the statement d of 2 equals 60, that for an input of 2, the value of the function d is 60. Functions can be used to model real-world relationships. So they want you to take this d of 2, well, except we're going to call it f. All right, so we're taking this here and we're going to plug it in. So if f of t models the outside temperature in degrees Fahrenheit, t is the hours after 6 a.m. The statement f of 2 equals 60 has a specific meaning. So what it's saying, so f of 2 equals 60 can be interpreted as, so this is going to be 2 hours after 6 a.m. So we start at 6, so whatever's in here is how many hours you add to 6. So 2 hours after 6 a.m. is 8 a.m., right? So at that time, the outside temperature is going to be what it equals, which is 60. So it's saying 2 hours after 6, which is 8 o'clock, the temperature is 60 degrees. That's what f of 2 equals 60 means in this context. All right, let's look up here. Let me just flip over a second. I want to make sure I didn't leave myself more work than I have time left because I'm doing this during my planning. All right, number 2. Physics students drop a ball from the top of a 400-foot high building and its height above the ground as a function of time using the function h of t. So this is how much time. It equals 400 minus 16 t squared. The height is measured in feet and time is measured in seconds. Find the value of h of 0. So h of 0 means 0 seconds. 0 seconds. So if we took the ball to the top of a 400-foot building and we haven't let go of it yet, the ball It's still at 400 feet, right? Because it hasn't left our hand. But let me show you mathematically why it's like that. So h of 0 is going to equal 400 minus 16 times 0 squared, because we're plugging in 0 for t. All right, this gets a little small. But 0 squared is 0, right? And 0 times anything is 0. So all this is 0, plus or minus. So you have 400 plus 0 or 400 minus 0. Either way, you only have 400 left. Make sense? So what does that mean? Oh, I found the value. Yeah, so at 0 seconds, the ball is at 400 feet, because it hasn't left. Evaluate h of 2. All right, so h of 2, it equals 400 minus 16 t squared. We plugged in 2 for t, right? All right, 2 squared is 4. 4 times 16, 4 times negative 16, this 400 comes down. We haven't messed with it. That's going to be, where did my calculator go? So, 16 negative times 4 is negative 64. 400, get out of the light, minus 64 is 336. So h of 2 equals 336 feet. So interpret the meaning. So at 2 seconds, we're just going to say ball equals 336 feet. Okay? All right, let's look down here. So Jose is asked to interpret the value of h of negative 3. Is interpreting the value reasonable in the context of the situation? So we can plug this in, and if you plug it in, you get a number like 256 feet. We're talking about time. Have you ever had negative 3 seconds? Can you go back in time? I don't have a time machine. I don't think you do either. So is it reasonable? No. Why? Because you can't have negative time. Just erasing this. We worked it out in class, and that's what we got. So you can't go backwards in time, so you can't use negative number in this particular function. All right, flip it over. Hurry up. Make sure we get a good lesson in. So, page 18. We've got h of t. So this is the same function. So at 0 seconds, 400 feet. Remember, x is so it's x comma y. X is the input, y is the output. Okay? Remember, we can't go back in time. So we're really looking here. So at 5 seconds, should be 0. 0 would be the ground, right? All right, so based on the context, the x-axis, so left to right, this represents the ground. And the y-axis represents the ball. You could also put the ground, but it's also time. Like how, and then the ball is all, no. This is time, this is feet. Sorry, so, hold on. The ground is distance, and the ball is time. It's how long the ball has been falling. All right, so what will the height be when it hits the ground? Well, the ground is 0 feet, right? And you know that from here. It asked you circle the point where the ball hits the ground. That's here, because it's 0 feet. Hard to see that. Hang on 1 second. That maybe you can see a little bit. This is 5, 0, so at 5 seconds, 0 feet. All right, right at the point where the ball hits the ground using the function. So time, the x is 5, and 0 for when it hits the ground. So h of 5 equals 0. So at 5 seconds, the ball hits the ground. How long did it take the ball to hit the ground after it was released? 5 seconds. and discuss with your partner. I want you guys to plug this in. Remember, it's negative 400, no, it's equals 400 minus 16 t squared. You plug in these. What you're going to see is 1.8 seconds. It's going to be, the ball is going to be a bigger number or taller, higher up than it is here. Because the longer it falls, the lower it gets. So you guys will see that. Okay, let's move over to the next page. We got page 19. All right, so 3.3. So the population of grizzly bears at the Yellowstone National Park has been threatened with local extinction since 1975. Through many conservation efforts, grizzlies have made a remarkable recovery. The function y equals g of t is modeled below, where t is the number of years since 2009. Even though they're talking about 1975, we've been measuring since 09, and g is the number of grizzly bears. So label the x and the y axes based on the context. So your time is here. That's how many years since 09. This is your x. And then up here, that is your y. And it's always x is going to be left to right, y is always up and down. All right, so B, approximate value for g of 3. So we go to 3, so 3, and you look up. And if you look, it's just above 700. This says approximate, not equal. So it's approximately, you can say 700. We're going to say 705, and I'm going to pause. Hold on. Okay, sorry about that. All right, so up here, in context of this problem, g of 3 means that 3 years after 09, so if you count, that'd be 2012, there are approximately 705 bears in Yellowstone. Find the approximate value for g is 8.5, so we go halfway between 8 and 9. You go up, that's going to put it just, it's actually a little lower. That's why I said 705 here, so we're going to say 701. So what does that mean in the context of the problem? So 8.5 years after 2009, we'll just say the grizzly bears equal approximately 701. Explain why there's not a value of t such that g of t is 710.5. Well, it looks like it doesn't go any higher than about 710.5. I would say their population so the bear population did not exceed approximately 710. All right, flipping this over, I'm gonna do number 2. Leave number 3 you guys to work. If you have questions, let me know in class. And then over here, whenever it says try it, that's what you guys are going to do. So I'm going to do number 2 real quick. You guys work 3, the try it, and that'll be the end of lesson 3. All right, so Matthew filled the bathtub. He took a bath, and then he drained the tub. The function B of M gives the depth of water in inches, minutes after he began to fill the bathtub. So explain the meaning of each sentence in context. So B of 0 equals 0. So at 0 minutes was 0 water. Why? Because he hadn't turned the water on. Now this gets a little confusing. It says B of 9.5 equals B of 20, which this means so at 9.5 minutes, water level was the same as 20 minutes. Why? Well, because he turned the water on. And then here, discuss with your partner why the inequality B of 1 is less than B of 7. And it's because at 1 minute, he's ran less water than at 7 minutes. So if you run water for 6 minutes, you're going to have more water than you did when you started, right? All right, so use this information in this graph, h of 10. So remember, h is going to be, this is your x, this is your y. There's your hint. If you have any questions, let me know. Parent Square, email, or you can comment the video. Until next time, have a good night.